Water is an excellent solvent. Aqueous solutions are where you have water is the solvent. For example, if we had a solution of sodium chloride itself would be the solute. And then the solution, we could say NaCl, and we could write aqueous. That means it's dissolved in water. This would be our solution. Okay. What I want you to understand is how does water actually dissolve ionic compounds? So our example we're going to look at is using sodium chloride. And a little bit of review, sodium chloride has ionic bonds. And what we learned earlier is ionic bonds are when we have cations attracted to anions. Cations are positive, anions are negative. And we could tell if a compound has an ionic bond by the type of elements. So sodium is a metal, and on our periodic table our metals are on the left. Metals always form cations or positive charges. So sodium always forms a +1 charge, versus chlorine is a nonmetal, and nonmetals form anions with negative charge. So chlorine always forms a -1 charge, forming chloride. So the ionic bond is actually the transfer of electrons between sodium and chloride. So we get this complete charge separation, and it's the attraction of the positive and the negative charges that makes our ionic bond. Versus we have water, H2O, and in H2O it's made of hydrogen and oxygen, and those are both nonmetals. And the bonds between nonmetals are covalent. And in covalent bonds, they share electrons. Okay, versus ionic, they transferred electrons and they have charges. So in covalent bonds, we don't usually think of them having as a charge, but covalent bonds can actually be classified further as what we call a polar covalent bond or a pure covalent bond. Pure covalent bond is where they would be sharing the electrons equally. We're going to talk about water because it has what we call a polar covalent bond. And this is the unequal sharing of electrons within a bond. So here we have oxygen and we have hydrogen. The stick or the line here represents the electrons that are being shared. And we can kind of think of this as a tug-of-war situation. So in our two atoms, they're not equally as strong. In this case, oxygen is stronger at pulling the electrons towards itself. So maybe in my tug-of-war here, this man looks like he's winning the tug-of-war. He could represent oxygen, and then the lady would be the hydrogen. So in this case, they're both sharing the electrons. Remember, a bond is sharing 2 electrons between our atoms. He's pulling the electrons more towards himself, and electrons have a negative charge. So the more he pulls them to himself, the stronger the partial charge is, what we call this. This delta represents a partial charge. There's a very, very slight charge on the oxygen, and when the electrons are being pulled away from hydrogen, hydrogen ends up developing a very, very slight partial positive charge. So this symbol here represents it's a very, very slight charge. So they're still sharing the electrons. It's still a covalent bond, but there's a slight partial charge on the hydrogen and a slight partial charge on the slight negative partial charge on the oxygen. And it's these slight charges which allow water to dissolve ionic compounds. So what happens here is we can see here we have a beaker with water. We put in our salt, it's sitting at the bottom, and we know if we mix it up, it's going to look like it disappears. It's still there. We still have salt water. So this is showing how it would actually dissolve. So what happens here in my molecules, let me blow up the next slide, it's a little bigger. You can see that here's my water molecule. This is hydrogen with the slight positive. This is oxygen with the slight negative. So it's the slight positive that's attracted to the chloride because opposites attract. And it's the slight negative that's attracted to the sodium positive. And what that happens is they pull apart my sodium chloride. So here we have a crystal structure. This would represent my solid sodium chloride. And when the water, we can say it sort of attacks it with its slight negative and slight positives, pulling the opposites apart, it ends up making my sodium ions and my chloride ions separated from each other. So you end up in your solution of having these chloride ions and sodium ions. There are some charges inside the water. The ions separate. So that's basically how water does. This slide shows how water has hydrated our sodium chloride. So hydrated is also sometimes known as solvated. Our solvent is the water. And again, showing you the same thing. Our sodium and our chloride have separated from each other. And we have chloride, if we look at that, it was due to the partial positive charge of the hydrogen ions, of the hydrogen portion of the atom in water that's attracted here, that slight positive to the chloride. And then our sodium ion was separated and is completely surrounded by water. And again, it's the slight, it's hard to see on the red, the oxygen, the red portion here, with the slight negative that's attracted to the sodium. So all of the slight negative of the oxygens in the water are attracted towards the sodium, just showing you how it's oriented, and that the sodium and the chloride are both completely surrounded by water. That's known as being hydrated. This can be any type of ionic compound. It doesn't have to be sodium chloride. Again, in salt, in chemistry, means any ionic compound. So we have an example of another one here. We have KF, potassium and fluoride. Potassium is a metal, and fluoride from our original fluorine is a nonmetal. So we have, again, an ionic bond, and it's the same process that would occur here. Whatever the cation might be, in this case, this would be potassium. This would represent fluoride. The water molecules, again, the opposites are attracting. So in the one at the top, we have potassium, and then the negative portion of oxygen in my water molecules attracted, separating that away from the fluoride, and then the water, the hydrogen positive portions are working to attract to that fluoride, ending up separating into our salt into a solution.